As robots move from labs into our homes, clinics, and workplaces, safety becomes non-negotiable. This workshop brings together world-leading roboticists, AI researchers, engineers, and certification experts to rethink how we model, control, deploy, and trust robotic systems. In our ideal world, robots are friendly companions. They share spaces with people of all ages. They support, assist, and collaborate, seamlessly, confidently, and intuitively. In that world, safety feels invisible. But sometimes, robots fail. Whether due to sensor limitations, planning mistakes, or simply unpredictable environments, even the best systems can behave in ways we didn't expect. And when that failure happens near a human, it's not just about technical errors. It's about risk, injury, trust, and liability. Safety failures erode public confidence and delay real-world deployment. We need robots that can act safely, and more importantly, prove that they are safe. We need systems that are robust and safe beyond the lab, that think not only about avoiding collisions, but also prepare for what happens if a collision occurs, that use human models, pre-collision guarantees, and reflex control strategies to minimize harm. We must combine strong model-based reasoning with AI-powered perception and prediction, before, during, and after an unexpected contact. That's exactly why we built this workshop, to bring together experts across modeling, control, biomechanics, cognitive science, and certification, to shape a unified framework for the next generation of intelligent, trustworthy robots.
We envision a future where robots are not just functional, but truly realistic. Systems that work with people, around people, and for people, in ways that are physically, cognitively, and socially safe.
This workshop is important because safety concerns all of us. Not only one person, not only one group, but all of us, and we all need to work together.
Safety is not just a feature, it is a system-wide responsibility. At our workshop, Build the Safety Robots takes a holistic view on the safety, include interacting modeling, control, and implementation.
Whether we talk about physical safety, like collision protection and musculoskeletal health, or cognitive safety aspects, including psychological comfort, trust, and personal preferences. Robot behavior must always adapt to each individual user.
Robotic safety is no longer just an engineering challenge. It's a fundamental requirement, and intelligent system has been integrated into every aspect of our lives. So in this workshop, we address this challenge head-on, discuss theoretical models and a deployable solution to build truly trustworthy robots. And we are delighted to host this discussion in the beautiful city of Hangzhou, that has both centuries of rich cultural heritage and cutting-edge innovation.
We have an amazing lineup of speakers looking for insightful discussions with all participants. Our workshop is intentionally interdisciplinary and inclusive. The speakers were carefully selected to represent safety in its full spectrum. From control and perception, to design and human modeling, including generative AI methods and deployment challenges. Expect technical depth and real-world applicability.
This is not just another workshop. It's a call to rethink how we design and control robots, how perception plays a central role in ensuring safety, and how we can integrate the next generation of machine learning and AI within a structure that is certifiable, interpretable, and safe by design.
Truly, making robots safe requires us to look at a lot of different perspectives. We need to consider biomechanics, we need to consider psychological hazards, and we need to especially make sure that we can embed all of these into robot control safely and reliably.
As robots become more intelligent and physically capable, they are moving closer to humans, working in homes, hospitals, and factories. But this raises a critical question: how can we ensure they serve us safely? Therefore, safety is not just a constraint. It is indeed a system-wide enabler, spanning injury biomechanics, economic design, control, and certification aspects.
If you are build a robot that move, interact, and decide, this workshop is for you.
We invite you to contribute your work. Please submit a paper by September 20th. All submissions will be reviewed by at least 2 experts. Accepted authors are invited to join our interdisciplinary impact clinics, a unique format where academic and industry professionals offer live feedback to help you maximize your research's practical relevance. The best paper will be awarded a financial prize, thanks to our sponsor Nokoff Motion Capture. We look forward to receiving your work and seeing you in Hangzhou.